In this video, we are going to see some examples on type first, that is direct differentiation. Examples on direct differentiation. Let's see one example. U is given, find its derivative uxy. What is uxy? First differentiate with respect to y, then with respect to x. So let's find its derivative. Differentiate u partially with respect to y, which is derivative of u with respect to y keeping x constant. Now in u there are two terms. So differentiate separately. In first term, x square is going to be constant. Differentiate only tan inverse y by x. In second term, both the terms has y. So use here product rule. Y square as it is, derivative of tan inverse plus tan inverse as it is, derivative of partially with respect to y of y square. In first term x square as it is, tan inverse derivative 1 by y square by 1 by 1 plus y square by x square, and further chain rule derivative of y by x minus in bracket y square as it is, derivative of tan inverse 1 upon 1 plus x square by y square by chain rule derivative of x by y. In second term, tan inverse x by y as it is, derivative of y square 2y. Simplify this fraction now, which is 1 upon x square plus y square. By taking reciprocal, we get numerator x square. Now derivative of this term. Variable is y, therefore x is a constant. Therefore 1 by x constant, y derivative y. Now in bracket, simplify this fraction. 1 upon y square plus x square. By taking reciprocal, we get y square in the numerator. Now differentiating this part. X is going to be constant, 1 by y derivative with respect to y minus 1 by y square. Simplify this. 1x cancels here. So 1x is here, x into x square, x cube. Multiplying this minus sign inside, we get first term positive, y square cancels, xy square by x square plus y square. Second term multiplied by minus sign, 2y tan inverse x by y. Simplifying these first two fractions with similar denominator, taking denominator common, we can take x common in the numerator. So bracket gets cancelled, we get this value as x minus 2y tan inverse x by y. This is first part, that is derivative of u partially with respect to y. X minus 2y tan inverse x by y. We have to further differentiate this partially with respect to y. Partially with respect to x. Now, first term is x, so its derivative with respect to x is y. In second term, 2y is constant because we are now differentiating with respect to x. X is there in tan inverse, therefore we have to differentiate this term. Tan inverse. Tan inverse derivative and further multiply partial derivative of x by y with respect to x. We get in left hand side dou square u by dou x dou y 1 minus 2y. Simplify this fraction. By taking reciprocal, we get y square in the numerator. Now 1 by y constant, x derivative with respect to x is going to be 1. 1y cancelled. Simplify the fraction. Minus sign multiplied here. So we get this value as x square minus y square by x square plus y square, which is the required answer. Dou square u by dou x dou y is nothing but u x y. So keep the order here. First u and then with respect to x. Let's see one more example. U is given x raised to y. Then show that these two derivatives are same. Now what is the left hand side derivative? Differentiate u first with respect to y and then twice with respect to x. And the derivative on right hand side, differentiate u first with respect to x, then y and then with respect to x. Now let's find the derivatives and show them same. So let's find these two derivatives. First, differentiate u partially with respect to y. Now, x raised to y. X raised to y. We have to differentiate the u with respect to y. So, variable is y, x is constant. Then this is similar to a raised to y. How you will differentiate this? A raised to y log a. So here derivative of u with respect to y, x raised to y log x. Okay. So taking x raised to first simplify, we get y x raised to y minus 2, y minus 1, x raised to y minus 2, 1 plus y log x. Taking x raised to y minus 2 common, we get y plus y minus 1 into 1 plus y log x. This is left hand side value, left hand side derivative. Now let's solve on right hand side. Again, we are going to differentiate this partially with respect to x. Derivative is going to be c. This is dou square u by dou y dou x. Differentiate this further partially with respect to x. Bracket x raised to y minus 1 as it is, bracket derivative with respect to x. So 1 derivative 0, y constant, log x derivative. Now term derivative with respect to x, therefore y constant, x variable, y minus 1, x raised to y minus 2 into bracket as it is. One plus y log x. Simplify this. X raised to y minus 2 into y minus 1, x raised to y minus 2, 1 plus y log x. Now taking x raised to y minus 2 common. Y plus y minus 1 into 1 plus y log x. So this is right hand side derivative. Value of dou cube u by dou x dou y dou x. Actually, second order derivatives values are same, and further on both side we are going to differentiate with respect to x. So value is going to get same, but still for the practice of partial differentiation, I have done the derivative on both sides. This is derivative on right hand side, this value, and this is derivative on left hand side, dou cube u by dou x square dou y. These two values are same. So we have done with two examples on direct differentiation.